All right, so this is lecture number 3, and I would like to show you how to obtain deal.II and how to install it. So let me start first by saying what the sort of thing is that you need in order to use deal.II. So we try to be fairly cross-platform. So what we usually do is most of us develop in Linux. Most of scientific computing happens in Linux for good reasons, actually. But then we recognize, of course, that most people at home have either a Macintosh or a Windows machine. My laptop actually runs Linux, so that is not that much of a problem these days. But most machines today still are Mac or Windows. All three of these should work one way or another. And I'm going to talk to show you later how to do it on Linux. It works almost exactly the same way in Macintosh, and Windows is a little bit more complicated. You find the instructions online for this. Then the things that you need on top of this is a C++ compiler. Typically on Linux and on Macintosh you have the GNU C compiler or GNU C++ compiler, but you can also use the Intel C++ compiler, or you can use something that's relatively new these days in 2013, namely a compiler that's called Clang++ that's built by Apple and that you find on newer Macintoshes. Other software that you need is Perl, CMake. You need stuff that you can use to visualize output, and I'm going to show you that at a later point. And you probably need an integrated development environment with which to edit files and so on and so forth. And we're going to come back to that in lecture number 6. You need a bunch of disk space. deal.II is not small, and if you compile C++ code, it typically leads to a lot of disk space that you need, but I think that today is not that big of a problem anymore. You need on the order of 1 to 2 gigabytes. So let me walk you through this real quick, and then I'll show it to you in practice. What you need is first to go to deal.II.org and follow the link to the downloads. And then what you get from there is a file that we call a tar.gz file. Tar is an old program from the 1970s that is short for tape archive. So it used to be a file format that you use to compress or to package all the files in a directory or in subdirectories so that you can archive it onto a tape, which of course we don't have anymore today, but the file format survived. And then the ending GZ is for gzip. That's a compression program. So it takes the archive, which is just the files, and compresses it so that it doesn't take that much space. An alternative to this is if you want to use the current development versions of deal.II. So oftentimes when you have a question on the mailing list, for example, asking how do I do this or how do I do that, or in particular if you find a bug, for example, then one of the things that might happen is that we say, yeah, this is a bug, let me fix it. And so we write a patch, we fix it, we check it into our archive, and then out of this archive, or let's call it a repository, you can check out the latest version of deal.II. That's the current development sources. And you do this with a program that is called SVN, which is short for Subversion, which is a program that allows you to pull source code or any other kind of files from a central repository. And in order to get it from there, the command you need to run is called svn checkout. And then you need to give the source of where this data is, and that is in this case https://svn-deal.II.org trunk deal.II. These things are of course also listed online in the download instructions. So once you have this file, essentially what you need to do is you need to unpack it like I showed you with the tar command, tarx with this tarxvzf. And then you need to think about how this build process works. So essentially, you will end up with 3 different directories. One is the source directory that's called deal.II after you unpack it. And then there's a directory where the make system will put all the object files. These are the files that you get when you compile each one of the C++ files. And then there is a third directory where you put the final installation. So the final installation consists of the libraries, it consists of header files, and so on and so forth. So the first thing is we unpack the deal.II sources. Then we create this build directory. And then we use a program that is called CMake and compile CMake actually in the first step just figures out what the properties of your computer are. So what's the name of the compiler, what's the version of the compiler, what flags do I have to set, what functions are available, what other libraries are available, and so on and so forth. This is what CMake does. And so to CMake has, well, you need to pass two arguments. The first one is this -d CMake install prefix. And that I set this to /a/b/c. That is going to be the directory into which the final result will be installed. Okay, so remember we had the source directories, which is called deal.II. We had the build directory, which we created here as a subdirectory to deal.II, but it can be anywhere actually. And then the third directory is the install directory. This is this ABC. And then CMake, which you execute in the build directory, has to be told where the sources are, because I created the build directory as a subdirectory of deal.II. The source directory is just ... the directory one higher. And then you call make and make install. So make and make install first compile all of these C++ files into object files, and then install the library that comes out of this together with all the header files into the final location. This is a process that takes on the order of 1 hour if you do it like I'm showing you here with just make. But I'll show you a shortcut in a second where if you have multiple cores in your computer, then you can make this a lot faster. So for example, my laptop here has 8 cores, and I can do this whole process instead of an hour in about 20 minutes. On our development workstation at my lab, we have 48 cores, and I can do this whole thing in about 8 minutes. So there are ways to make this faster. And so after we're done with this, then you end up with the deal.II source directory, the build directory, the install directory. You can remove the build directory if you want. You probably don't need this anymore unless you plan on making changes to the library itself. And then you can try out whether that actually works what we just did. So for example, you can go into the step 1 tutorial program directory, which is examples step 1, and try to install that and run it. And so the way this works again is you call CMake. And in this case, you have to tell CMake where did you install deal.II. So -d deal.II dir equals ABC. This is the directory we gave up here. Okay, and then where are the sources for step 1? Well, in the current directory. And then we type make run. Before I show this to you in practice, I want to point out that there are many more flags that you can give to CMake. So I only showed you how to pass the installation directory, let's say the destination, and the source directory as arguments to CMake. But there are many other arguments. For example, if you have other libraries installed, like PETSI or Trilinos, you would have to pass the directories in which PETSI and Trilinos reside to the CMake command if it's not in any standard directory where it can automatically find it. Then you can instruct CMake to not just build the object files in the library, but for example, you could build the entire deal.II documentation locally as well. There are arguments for this that you can pass to CMake. Or by default, we build with multithreading so that your programs can run on multiple cores on an individual machine. If you don't want this, then you can pass other flags to CMake. So there's much more to be learned about this that I'm not going to go into detail here. But if you're interested in this, just go to the README file and you will find the instructions for this. OK, so let me actually show you how this works in practice. So on my laptop here, I open a shell window, and I have already created a directory mass676. And what I will do is I will go to the deal.II.org website. I will go to the download site. So there is a link to the place where you can download these files. So there are a number of different ones, different files, for example, for release 7.2, which is, as we speak today, the current release. I hope that we have 7.3 out within a few weeks, let's say at the end of January or February 2013. And then actually the sort of things that I show you today, how you install everything with CMake, is something that isn't even in 7.2 or 7.3 yet, but that will be in version 8, which I hope will be the version that is current by the time these videos will be up on the web. So if you click, for example, onto the complete deal.II release, it asks you whether you want to get this. Yes, I do. So I'm going to click on this. It's going to save this file. This is 76 megabytes. I'm fortunate to have a fast connection here, so it's going to take, 30 seconds maybe to download all this. I don't need this in this case here because I've already downloaded this. Or actually, I have downloaded the version that I hope will eventually become 8.0, so the one that essentially works like I just outlined with CMake. So I have a file that is called deal.II 8.0. It's a pre-release tar.gz. And forget about the other directory that I have here right now. So if I want to unpack this, I type tar for tape archive, and then this rather awkward combination xvzf deal.II 8.0 pre-tar.gz. So x means extract, so it takes a tar file and extracts it. V means verbose, so give me information about all of the files that you unpack. Z means that the file is not just a tape archive, a tar file, but it is also compressed with gz. And F means that it shouldn't take it from an actual tape device, but from a file. Of course, we don't even have tape devices anymore, so F is a flag that we always have to give these days. So if you do this, it unpacks all of these files, and I now have a new directory here that is called deal.II. So let me go into this deal.II directory, and let me show you what's there. So there's in particular source and include files. There is a directory for the examples, that's the tutorial programs that we have, and there's a whole bunch of other things. So like I said, the first step needs to be that we create a directory where you want to build, so where the object files will end up in. And this directory could be anywhere. I personally like it if it's a subdirectory of deal.II, because then I have it all in one place. But you can create this anywhere you want. So you could have it in the same let's say in the directory above, so it could be here, or it could be in a completely different directory. That's your choice. So one common choice, for example, would be to build in the /temp directory. But let's do it this way. So in the deal.II directory, I create a build directory, and I go in here. So the directory that I'm currently in, the present working directory, pwd, is in the math 676 deal.II build directory. And so in here, I now have to call CMake, and then I need to tell CMake where do I want to install it. Okay, so that is the deal.II install prefix equals, and let me install this, for example, in a directory home Bangerth bin deal.II 8.0 pre. Okay, so that is the destination, and then I need the last argument to CMake is always where are the sources. So the sources in this case are one level up. Okay, .. or just .. And so if I execute this, CMake will run, and like I said, what CMake does is essentially it tries to figure out all sorts of properties of your system. What's the name of the compiler? What are the bugs in the compiler that we have to work around? What is the name of the executable for the Perl script? What is, what are all the libraries that are available? And then at the very end, it shows us a summary. So for example, what it shows us here is that these are the flags for the compiler that it's going to use. So for the C++ compiler, here are some flags for the C compiler. There's a few files in the library that need to be compiled with C. Then it tells us, for example, that it has found the LAPACK library on my computer. It has also found the MPI library, so I can run in parallel if I want to. It has, let me go back to the bottom here, it has not found Trilinos, for example, okay, which is because I have this in a non-standard directory. So in my case, I would have to tell CMake where to find Trilinos. And it's not very difficult. If you go to the README file, it will tell you where to find this. Similarly, it hasn't found Petsy, and it hasn't found pforest, for example, another library that we can use. So most of the time, if it doesn't find any library, that's not a problem, because most of these other libraries that we can build with, you will not need. If you do need them, then you will know that you need them. And in that case, so for example, if you wanted to run the step 40 tutorial program, you know that you need to run with Trilinos or with Petsy in this case, and then you will know that you need it, and you will know how to find in the README file how to tell CMake that you actually want to use it. All right, so CMake set up what is available. And the next step then would be that I build the entire library. So as I say, I can do either make, and that's going to take a very long time. So it goes through all manners of files and tries to compile every file individually. Okay, so you see that after 20 seconds of talking, I'm at about 1% of the overall build process. And this would go on for a long time. But let me abort this here. One of the things that that can make this faster is that I have multiple processors, multiple cores in this laptop. And the way under Linux to find out how to do this is that I cat, so that means I copy to the screen a file that is called proc CPU info. Okay, and it tells me that there are a total of, it lists all the processors that are in my machine. So in this case, the total number of processors I have it counts from 7, so there's 8 processors in total. So one of the things that I can do is I can say make minus J8. And that means it starts 8 compiled jobs. So J stands for jobs, and that means it builds 8 files at the same time, and that can make this whole process a lot faster. So I aborted this again because it will still take 20 minutes, and my cameraman has just showed me that I have 15 minutes left, so I can't do this here. But ultimately, this is the way you would do this. So go get yourself a coffee and wait for it to be done. Now, the last step would be to say make install. Okay, make install takes all of these object files, puts them into the library, and installs the libraries and the header files into the final destination. I don't need to show you how to do this here because I have already done this on my laptop, and I'll show you how this looks. So the final destination to install was home Bangerth bin deal.II 8.0 pre. So this is what ends up in this directory. So for example, you will have a subdirectory include deal.II, which has several subdirectories, and for example, in the subdirectory grid, there are these sort of header files. These are the things that your program will need to know, that they describe the interfaces of deal.II. Similarly, there is a lib directory, a directory where all the libraries are, and you will see that there are 2 different libraries in particular, namely libdeal2.g.so and just.so. These are the debug and optimized versions of the library, and we'll come back to that, what the differences between these 2 are. But this is essentially the result of calling make and make install. So what I wanted to show you is what happens if you actually did all this. Can we verify that it works? And so let me go back up 1 level, and I'm in the deal.II directory again. And from there, I want to go into the directory examples, step 1. That's the place where the tutorial programs are located. And so this is the very first tutorial program. It's called step1.cc. So what I'm going to do is I'm going to call CMake in this directory. Okay. Then I need to tell CMake where are the deal.II sources or installed, or sorry, where are the deal.II libraries and header files installed. So I say CMake minus d deal.II directory dir equals, well, I installed at home Bangerth bin deal.II. Okay. Where are the sources for the thing that I tried to compile right now, namely the step 1 tutorial program? That's in the current directory, so dot. Okay. And so if I run this, it again detects all sorts of compilers. It stores where the deal.II directory, the deal.II libraries were installed, and so on and so forth. And at the very end, it says configuring done, generating done, build files have been written to the current directory. Okay, so when I have this, now I can say make, okay, and it's going to compile step 1, and link it with the libraries for deal.II that we have built previously. And so what I end up with is something that looks now like this. So there's all sorts of CMake files and directories. What exactly is in them is not really of much of our concern, but what I can do, for example, is I can say make run. Okay, make run is a target that executes the current tutorial program. So if I do this, then it says running step 1 with debug configuration. Okay, so that means in this case I have built this tutorial program with all sorts of debug information, with assertions and so on and so forth. And it runs it. And what I end up with is in particular 2 files that are called grid1.eps and grid2.eps. And we're going to look at step 1 at this tutorial program in lecture 5 in much more detail. So you will see what should be in them. But let me show you for now, just to verify that everything went all right, what this grid2.eps looks like. I do this with a program that is called Ocular, which is under Linux one of the programs that are, let's say, universal viewers that allow us to view pretty much any file format. And so it's going to show me a picture like this. So it's a mesh that is adaptively refined that shows an annulus. Okay, and that, let me assure you, is how the output of step 1 should look like. So we've built deal.II. We've verified that it actually works in practice. And that is essentially all of the things that I wanted to show you for this class. I want to point out one thing. So if you're not entirely comfortable with working on a command line, so of course today most of us learn to use computers with Windows or with any windowing environment. And if you do this, then you're not that familiar anymore with working on a command line. I reveal my age here. I grew up in a time when everything was on the command line. And so for me, this is very natural. But this is not how I see it happening with my students today. So if you're not completely comfortable working on a command line, there is a website that is called Software Carpentry. And if you Google for this, you come out at softwarecarpentry.org. And Software Carpentry is a project that has a lot of training modules for, let's say, how to generally be a computational scientist. So it teaches you about what do you do with a command line, what do you do with a version control system, how do you use a programming editor, and so on and so forth. So there's all sorts of lessons where you can look up stuff here. Okay, so on regular expressions, and so on and so forth. So if you're not completely familiar with working on, let's say, a Unix environment or working with a programming environment, Software Carpentry has a lot of information for you. All right, so I think we've covered the basics of installing things. Before we finish this lecture here, I would like to point out a couple of things. So one of the things when you work with deal.II is you will find it very useful if you join the deal.II community. So there's a mailing list, or actually there's multiple mailing lists that you can join, but there's one in particular where you can ask all sorts of questions. And of course, where you can also see what other people ask as questions. So you learn a lot by just watching other people ask questions to see what they do and seeing the answers, right? Because oftentimes what other people have as questions is something that you will find to be something that you're not completely familiar with either. So I really want to encourage you to look at joining these mailing lists and learning what the material is that's asked there. The other thing that you probably want to do at this point after you've built this is that you go to the deal.II website and you look at the place where we talk about the manual. The manual is the documentation of the individual parts of deal.II, so where all of the functions and all of the classes are documented. And in particular at the tutorial. The tutorial is a collection of example programs that walk you through how to use deal.II. So the address is given down there. And if you go back to deal.II here, so if we were here, so you would pick, for example, the version that you want to use. Let's say I want to use 7.2, and then you would click here on the tutorial, and you would get to see the overview of all of the tutorial programs that there are. So that's going to be the first place where you enter deal.II and where you can learn about how to use it in practice. All right, and yeah, these are the tutorial, the manual. There's more resources. For example, you can go to the frequently asked questions if you don't know how to debug a particular problem, or if you don't know what an error message means. Many of these are listed on the frequently asked questions. And with this, I conclude lecture 3, and we'll come back to using the first tutorial program in lecture 5 at a later time.